Hello friends, welcome to this video. Let's start with the solution of LTC AIIMS chemistry weekend test number 20. So here is first question. Match the following elements in column 1 with the methods of purification in column 2. The correct answer is option 2, right? Because boron is refined via zone refining and tin is refined via liquation because it is a low melting metal. Zirconium via Van method and nickel via Mond's process. The method of zone refining of metals is based on the principle of the greater solubility of the impurity in the molten state than in the solid state of the metal. If the impurity in a metal has a greater affinity for oxygen and is more easily oxidized than the metal, then the purification of metal may be carried out by cupellation. For example, lead impurity in silver, lead is oxidized as PbO. All are purified by zone refining except nickel. Nickel is refined via Mond's process. Zone refining method is very useful for producing semiconductors. Yes, both statements are correct. The correct answer here is option 1, that is A matches with 4. Yes, cyanide process is used for the extraction of gold and silver, right? So this matches with this. B matches with 2. Flotation process is used for the concentration of sulfide ores. Yes, zinc sulfide is an example. Electrolytic reduction is used for the reduction of alumina, right, to aluminum. And zone refining is for ultra pure germanium. In the extraction of aluminum, this is the correct answer, that when iron oxide is a main impurity, the process used is Bayer's, and when silica is the major impurity, then the process is Sapex. In Ellingham diagram, which of the following metals can be used to reduce alumina? That is Mg, because the reducing agent must lie below the metal. The process which involves smelting is the reduction of a metal oxide with a suitable reducing agent. So this is the correct option. This is roasting, this is calcination, and this is calcination. So this is the correct answer. Metal oxide which cannot be reduced to metal by carbon is Al2O3 because it's a highly stable oxide. In this case, if you notice, half mole of oxygen gas gives 1 mole of carbon dioxide, so the number of gaseous moles increases, so entropy changes positive, right? And as per the equation, delta G is equal to delta H minus T delta S. If delta S is positive, then with increase in temperature, Gibbs energy decreases and the slope is negative. So this is the correct answer. Endothermic process of the following is this, because carbon monoxide is less stable than carbon dioxide. Carbon and hydrogen, although they are good reductants, but they cannot be used to reduce metal oxide at higher temperatures because of the formation of course, carbides and hydrides at high temperatures. Which of the following is a organometallic compound with sigma and pi bonded? This is ferrocene, right? Oxidation state of central metal in cisplatin is PtNH3 twice Cl2. It's a neutral compound and 2 negative means 2 positive. So the oxidation number of platinum in both the cases is plus 2. Primary valency is ionizable, it is 2. Cobalt third chloride forms several octahedral complexes with ammonia. Which of the following will not give test? Of course, the chloride should be inside the coordination entity, and which is possible only in this, because for an octahedral complex we need 6 ligands. 3 would be provided by 3 ammonia and 3 chloride. So there wouldn't be any chloride left outside of the coordination sphere. Identify incorrect statement regarding the complex. This primary valency of the central metal ion is 2. It is not 4. The other statements are correct. Which of the following is the correct value of X? So the complex is CrCO6 octahedral complex. 2.82 bm means there are 2 unpaired electrons, and NiCO4, NiPPH3 4, and NiCyanide 4, all these are not having any unpaired electron, they all are diamagnetic. But in case of NiCl4 2 minus, the configuration is D8. So of course we have 2 unpaired electrons, which contributes to 2.82 bm of magnetic moment. Low spin in D4. So the electron, if we talk about the 4th electron, it went in the T2g orbital. It happens when the pairing energy is less than the crystal field splitting energy. So this is the correct answer. For an octahedral complex D4 configuration, delta is less than P. Pairing energy is more, so we will not spend pairing energy. Of course, we will spend crystal field splitting energy. and then the fourth electron will go up. That means the configuration would be T2G3 and EG1. So this would be the correct answer. Based on CFT, the correct relation is of course this, because in octahedral complexes, number of ligands is more and the angle of approach is more direct. The correct statement about the magnetic properties of these two complexes, if you analyze, then you will find out the oxidation number of Rn is +3 in each case. So the configuration would be D5S0. With 5 electrons, it doesn't matter whether the ligand is strong or weak, you will have one unpaired electron. That means both would be paramagnetic. According to the valence bond theory, which of the following is an example of outer orbital complex? So of course, here again the oxidation number of Rn is +3, which means D5, and all the d orbitals are singly occupied, and fluoride being a weak ligand cannot pair them up. So we would be using 4d orbital for the hybridization, leading to sp3d2. That is outer orbital complex. It would be. Irrespective of the strength of ligand, it would not matter for chromium 3+, because chromium 3+ has D3 configuration, right? The strength of the ligand matters in these configurations, D4 to D7. Silver forms many complexes. Some of these are, which of the following statements is true? All these complexes are linear, of course. Metal is a Lewis acid, not base. The hybridization of silver is sp, linear, and they're not good reducing agents. Which of the following is an optical isomer is here? Because it is non-superimposable on its mirror image. The facial and meridional isomerism is exhibited by the complexes of this type, where there are two types of ligands, 3 each. The CO bond length is inversely proportional to the oxidation state of the metal ion, right? Because carbon monoxide is neutral. So in this case, the oxidation number of metal is -2. So lowest is the oxidation state, maximum would be the carbon oxygen bond length. So this would be the correct answer. A metal ion forms 4 tetrahedral homoleptic complexes. The complex with maximum stability is the one with the overall instability constant of minimum, of course, because instability constant is inversely proportional to stability constant. Now stability is proportional to stability constant, so it would be inversely proportional to the instability constant. So it is very simple. You just have to express in the scientific notation. So this would be 5 × 10⁻⁴, and this would be 3 × 10⁻⁶. So this is the lowest value. So that means this corresponds to the most stable complex. Both statements are correct, of course, because EDTA a hexadentate ligand, its complexes are highly stable, and nickel is a transition element, aluminum is a non-transition, it's a B block element. Molecular weights of drugs are in the range of this one. Further growth of cancerous cells in the body is arrested by chemotherapy. Again, you have to memorize the use of all the drugs that are there in your chapter, Chemistry in Everyday Life. So for this question, the correct answer is option 3. Carbon, gold, sulfur, noble gases, all of them can exist in the free state in nature. During smelting, an additional substance is added which combines with impurities to form a fusible product, which is known as slag. Flux is added to the gangue to give slag. Percentage of carbon in cast iron is 3%. Theoretical, you have to learn it. The functional groups present in aspirin are: aspirin is 2-acetoxy-benzoic acid or acetyl salicylic acid. So this would be this one. So there is an ester functional group you can see here, and there's a carboxylic. So this is the correct answer. In human body, proton cell gets converted to sulfanilamide. How many of the above compounds are identifiers to laundry soaps? All of them. Drugs which mimic the natural messenger by switching on the receptor called agonists. All of the following carbonate ores except barytes. Barytes are basically barium sulfates. Salvarsan is an antimicrobial agent used to cure syphilis, contains arsenic double bond. So this is the correct answer. Again, a theoretical question. The correct answer is option 1. Which of the following is taken as a standard? Of course, sucrose. An artificial sweetener is 600 times as sweet as sucrose and does not provide calories. It's prepared from sucrose by selectively replacing 3 OH groups with chlorines, and the resulting product is called sucralose. You must have heard of it. So this is the correct answer. The false statement is diabetics use artificial sweeteners. No, to decrease the calorie intake, right? Which would otherwise be caused by sugar intake. Detergent X is prepared by reacting stearic acid with polyethylene glycol. Regarding X, the incorrect statement is it is used as a hair conditioner. No. In this, again, it's theoretical. The correct answer is option 1. Thank you, guys.